Hey, welcome back to my channel. Um, so for this video, and hopefully future videos, I'm going to play Sudoku. What I normally do is I play Sudoku from cracking the Discord, I'm sorry, cracking the cryptic Discord page. However, what I'm going to do this time is just kind of introduce my strategy, not introduce myself or the game, but my strategy. Um, and then we're gonna get straight into a horror puzzle next time. So let's first of all learn the rules. There has to be one number, 1 through 9, in each column, row, and 3 by 3 blocks. The number 1 through 9 once each in those three. Now that sounds really easy, but the execution is actually really hard. Um, Let me give you a glossary of the terms I use. So first of all, one small block, one tiny square. I call that a cell. There are 81 of them. 81. A column goes up and down. There's vertical lines. There are 9 of them. A row is a vertical line. I'm sorry, horizontal line. And that's called, again, row. There are 9 of them. A 3 by 3 group of cells separated by the bold lines. That is called a block. There are 9 of them. A group of 3 horizontal blocks. I call that a line. There are 3 of them. One right here. And one right here. And then the group of 3 vertical blocks separated by the bold line. I call that a stack. And there are 3 of them. And then, of course, let me trace it all. There is a board itself, which I call a grid, which there's 1. So, first of all, what I did Well, first of all, let me explain why I'm making this channel. Hey everybody, this is Mr. A coming at you from the future in post-production. Um, I just want to let you know that if you are wearing headphones, this video is probably not for you. I have an Apple Pencil that I use, but I tend to tap way harder than I need to. Um, so sorry about all the hard hits throughout the video. Also, don't don't fret when you see the time. It does take me a long time to complete this puzzle. I'm probably the puzzle I play in this video is a New York Times medium from Monday. I'm probably more of a New York Times easy on Thursday kind of kind of uh, kind of difficulty. But that's not when I made this video. So yeah, this puzzle took me a long time. Also, I have so many post-production notes. Sorry about that. Um, I lost my train of thought. What was I gonna say? I'll think of it. I what was I gonna say? I don't remember. But anyway, I want to share my Sudoku knowledge with people, and I end up explaining more than I should. Um, so that's another part of why this video is so long. So, without further ado, um, oh, I remember. Sorry, I remember what I wanted to say. This video, I also tend to have. This is my first video, or first official video. So, I have some first video jitters to get out. They kind of leave in later videos, so little later videos are less jittery. Um, But no matter how many times I remake this video, it just keeps happening. Um, First video jitters. Sorry about that. I've also, one more note. I've noticed that if you have a hard time hearing my voice, I have noticed that turning the speed of the video up faster, you can hear my voice better during production, post-production. I use 2 times speed. Um, I implore you to try a little bit normal and a little bit 2 times or anywhere in between and tell me what you think is better. Um, and that's what I'll do. But for now, without further ado, enjoy. So, I'm not first and foremost, there's a huge asterisk, a huge star. I am not great at Sudoku. It will take me a long time to finish each puzzle, and that is expected. I am not the best at Sudoku. However, I know how to play Sudoku. And I do watch videos such as Cracking the Cryptic where they play Sudoku. However, they don't really teach for beginners. Actually, in fact, not many people do. You have to kind of do deep dive to figure out how to play Sudoku. And I don't think that's really worth the time. So I'm gonna try to teach as best as I can, even though I'm not great. Now, the first thing that you should not do is here I wrote down every number that could go in each of the cells in the first block. And the reason why you should not do that is because I had the time going while I put all these numbers in. And then I paused it immediately. It took it took me 1 minute if you look up in the upper right. It took me 1 minute and 35 seconds. If I did that for every block, if I did that for every block, it would take way too long. It would take almost 13 or so, 13 minutes before I actually start the game. There is one other reason though. If you fill in every square with every cell, with every number, it'll get very ugly and very distracting really quick. So actually, unless worse comes to worse and you get halfway done with the puzzle and there's nothing else, it looks like you would do normally, then don't do that. Um, only place or only make a little pencil mark if there are only two places that a number can go into. Let me find an example. Right now, not example, but right here is a good example. If you look at the 9 in these two cells, a 9 can go in those two, and it cannot go in any other cell in that block. So I gotta put in a pencil mark. But a 5 can go anywhere in this block. I can pencil mark. That is just too many places. So I am going to reset and we are going to get started. The first thing I like to do, if you heard the rules, each number can go in a block once. So each number can go in 3 blocks 3 times. So 1, and they can only go in each row once. So they will have to go inside 1 block in that row. Or it can only go in 1 row in a specific block. So I can have block 1 in the top row, block 2 in the second row, and block 3 in the third row. Or block 1 in the second row, block 2 in the first, and block 3 in the third, etc., etc. So I like to call this top, middle, bottom. A number has to go in each one, top, middle, bottom, but it doesn't matter which block. So, for example, the 1 goes in the bottom of block 1. So in block 2 and 3, they could be any of these cells. However, I only look at pencil marks, or I only deal with it if there are two numbers in a line. So I will deal with the 1, because in the top line, there's only one 1. But the 4s, there are 2. So I will deal with them. Or the 8s, there are 2 of them. So I will deal with that. If there are 3, in this case, it doesn't look like there's any scenario that. However, if there were, I would just ignore it. Because you have all 3 out of 3. So, let's look at a 1. There's only one 1. Forget about it for now. There's only one 2. Forget about it for now. There's only one 3. Forget about it for now. There are 2 4s, 1 in the bottom, 1 in the middle. So we need a top. However, because of this, I can block out this and put in a 4 here. Now let's look at the 5s. There are none. Let's look at the 6s. There's only 1. There's only one 7. I have a middle and a top 8. So I need a bottom 1. But this, because it won't be here. So I can put a big 8. There's only one 9. Don't forget about it. In the second, so now move on to the second line. The only 2 numbers that appear twice are 7 and 9. The first deal with the 7. We have a bottom, middle, we need a top. However, I can't narrow it down to 2 spaces, so I'm going to use this little corner mark. That little corner mark, it was, I don't know if it was discovered or just specifically used. And I don't know if he was even the first guy who started using that, but it's named after him. It's called Schneider notation. It was used by Snyder to help him be the world Sudoku champion. So that's really handy. Now with our 9, we know they are going to be here. I'm going to use my Snyder notation, which I more often call a pencil mark, or even more often a corner mark. Um, so now we will move on to the third line, and the only number that appears twice is a 5. I have a middle, a bottom, and a top. However, because I cannot narrow that down anymore of where the 5 will be, and that is more than 2, I'm just going to forget about it for right now. Now, we are done with top, middle, bottom. Now we will do basically the same thing. It's called left, center, right. You can only have one number in each block and one number in each column. So they will look the same, segmented into blocks, into rows. So it could look like that, or maybe like that, or whatever. So, and again, I only look for numbers that appear twice. And I see a 4 that appears twice. I have a left, I have a center. Oh, by the way, I call this left, center, right. So I have a left, a center, I need a right. However, because of this, I can rule out this. Now that I only have 2 cells, I can use my Snyder notation. I can use my corner mark and not make the puzzle look too ugly. And the only other number that appears more than once in this stack is a 9. I have a right, left, and a center. No corner mark that. Let's move on to the second stack with the 2s. I have right, left, and a center. Well, there's only one place it can go. So I'll do that. In this step, this is step number 2. Step 1 was top, middle, bottom. Step 2 is left, center, right. However, one very important part of step number 2 is ramifications. If we are able to place a number, then we have to go back to step 1 to see if they can help us. And if it can, keep on going until that doesn't help anymore. For example, if we use ramification to put a 2 here, we don't have to do it again on this stack. If we could put a 2 here, we have to do that with this row, which means that's a 2, etc., etc. So, and it looks like 4 appears twice, so we can pencil mark that here. 8 appears twice, so we can pencil mark that. And that's it. Now the third stack, it looks like a 3 appears twice, but I can't narrow it down any farther, so I will not make a mark. 7 will go here. And it looks like that's it. Now, let's see if the 7 does any ramification. It does not. So, let's move on to step number 3. What I like to do is highlight every cell that's still empty in every block individually and see where each number cannot go. So, kind of like I told you not to do at the beginning, but I won't fill it in unless I can fill it in, pencil mark it with Schneider notation. So for example, I still need a 2 in block 1. It can't go there. So I will pencil mark that. A 3. Because of that, it won't go there. But I can narrow it down more than that. And because there are more than 2 cells, I'll forget about it for now. I still need a 5. And then I'll go in one of these. And I can corner mark that. Because there are only 2 left. The 7, I will forget about. Now I move on to block 2. The 1, there's still more than 3 cells. So I'll forget about that. 6, there's still more than 3 cells. Forget about it. 7, 8, 9. Move on to block 3 with 1, 2, 3, 5, 5. It will pencil mark that. 6. I can also pencil mark. And a 9. I can also pencil mark. Now, these two are special because what this Schneider notation is actually saying is either or. In basic terms, either or. If, and so, basically a 9 either goes here or it goes here. So if somewhere along the puzzle I can say this will be a 9, what that'll tell me is that this is no longer a 9. This is no longer a 9. So this one is. However, if this one along the puzzle can I find out is a 9, then I could say this is not a 9. This one is. So, that being said, these two. If this one is a 5, then this one has to be a 6. A 6 cannot go anywhere else, and that's the only number left that can go into that cell. Same the other way around. If I put a 5 here, the only number that can go here is a 6. And it's also the only place left where I could put a 6. So what that is telling me is that one of them is going to be a 5 and the other one will be a 6. I can't argue that one of them will be a 5 and one of them will be a 6. So I'm going to use this special center mark, which tells me it's going to be one or the other. I can't place any other number in that cell, and I can't place that number in any other cell in that block. Like, for example, I cannot put a 2 right there because that is not one of the numbers in my magic pair. So, Anyway, where were we at? We were doing across me. We were here. So 1 doesn't help. 2 doesn't help. 3 doesn't help. 4 helps, but we already have that marked. 6 doesn't help. We already have 7 marked. And 8 doesn't help. So here, 1 doesn't help. We already have 2. 3 doesn't help. We already have 4. No 5 or 6. I already have 7. I could pencil mark my 8. It's already there. So are my 9. So I will move here. 1 doesn't help. 2 doesn't help. 3 doesn't help. 4 doesn't help. 5 doesn't help. 6 doesn't help. 7 is already there. And 8 doesn't help. And that's already there. So let's look here. 1 doesn't help. Neither does 2 or 3. There you got 4 or 5. 6 doesn't help. 7 doesn't help. 8 doesn't help. And there I am, my 9th pencil mark. Here, I need a 3, a 4, a 5. We'll go in one of these. A 6, a 7, a 7, which will go in one of these. 8. Oh no, I don't need an 8, sorry. But a 9 won't help. In this cell, I can see that a 1 will help, 2 will help. I got a 3, a 4 can be pencil marked. A 4 can be pencil marked. A 5 is already there. So are 6 and 7. 8 can be marked. And so can 9. And now it's time for me to tell a couple, I don't want to say hard, I want to say more advanced tricks. So, we have already solved what these tricks are. Do I see one right now? I only see one at the moment. And that is normally with left, center, right. You need two numbers. You need two numbers in the same stack. However, in this case, in this special case, you don't. And the reason is because this 9 can't go here. And this block is obviously already filled in, so it can't be a 9. So, this has to be a 9. And what that means is that neither of these two, neither of these 6 cells could be a 9. So the 9 has to go here. But because of this, that can't be a 9. So one of those two is a 9. Now, that didn't help us anymore, but just to show you, you can do that. What I will do right now normally I only make a matching pair as in these two. But in some rare cases, or not necessarily rare, in some cases, I will put a matching triple, but only if the triple is in two of these three categories. They are in the same block, they are in the same column, or they are in the same row. And this is one of those cases. So, I will fill in this triple with what is not accounted for in this block. So I know triple 1, 2, I have a 3, I have a 4, 5 and 6 are counted for. I have 7, I have 8, so I know I will need a 9. Now, that one can't be a 9. We already solved that one too. But it also can't be 1 because of this. So we know that it's a 2, which means these will be a 2. So we have another matching pair. Another that will give us another triple. It cannot be, or the triple has to be 1 is accounted for, 2, 3, 4, 5, 5, 6, 7, 8, and 9 is accounted for. So, this can't be 4. And that's it. Let's see what else I can do. I think I have reached the limit where, let me look. Oh, wait, no, I haven't quite exactly yet. I know using top, middle, bottom, I need a 2 right here. So that means now there's only one place a 5 can go. I have a matching pair with 3 and 7. However, because of this, that can't be 7, meaning it's a 3. That's, oh, that's a 7. Um, let's see. Now I can corner mark with 3s and my 7 because of it. Um, I am thinking that is also going to give me a 5 from left, center, right. Okay. It looks like that is now the point where I find rows, columns, and blocks with 1, 2, or 3 cells left. And hopefully I can place a number. If not, I will put in a matching pair if the matching pair is in the same block. For example, here there will be a 5, 6 matching pair. However, they are in a different block. So I'm not going to put that in there. And that's the only one. It looks like with 1, 2, or 3 cells left. So now, actually, I will go back through and look for cells. Look for rows, columns, and blocks that have 4 cells left over, such as the first one. And I still need a 1 there. A 5 can't go there. 7 can't go there. And 9 can't. What was over here? 1, 5, 7, and 9. The second row needs 1. Oh, let me look. 3, a 6, and a 9, which doesn't help. We have this, which needs a 3, a 5, six, and a 7, which will be one of these. Actually, complete that 7, this, and this. I mean, I can't go here. So, 7. I still gotta look for ramifications. Still gotta look for ramifications. So I can put it here. And a 4 right here. So, 7 here. A 7 here. 4 can now not go here. Has to go here. So this is now 3, 8 pair. Okay, so I had to take a break. It's now the next day. Um, that being said, I don't know where I'm at right now. So I am going to do all my tricks real quick until I get back. I actually noticed something. This cannot be a 5 because of that. So it'll be 6, the 5. Um, and left, or top, middle, on the bottom. Um, one of these will be a 6. Cancel. I don't know anything else. Um, I'll be back in just a few minutes unless I find something else. I have noticed this. I have a middle, a bottom, and the top 5 in this line. It doesn't look like that gave me any ramifications though. So back to work. So I was able to pencil mark my 5. And if you look up in this row, I still need a 1, a 5, and a 9. However, this and this tell me this one and this one can't be a 5. So this one has to be. Um, so I can also put this as the other pair of 1 9 in this row. So let me let me noodle for a minute. Um, Here down in this row, I need 1, 8, and 9. However, this and this get rid of this side, this. So this is a 9, which means this one's not. So what I am seeing is probably not right. I know for a fact that one of these will be a 9. Or I'm sorry, well, one of them will be 9. But right now I'm looking at the ones. One of them will be 1, and it will not be that one because of that. So I can triple with 3, 5, 9. This one, in this column, I need a 3, a 5, and a 9. This one and this one can't be 9 because of this and this. So this one will be the 9. meaning this will be the 1, the 9, and the 1. That's, did you see that? That's the advantage of matching pairs. Once you are able to solve one, it kind of becomes a snowball effect. And you, depending on how long the puzzle is, you can solve a lot of numbers with one matching pair if you use matching pairs. Anyway, I know that's a 3 because of the row and the column. Let's see. Let me do this again. So, looks like I can pencil mark the 1 in, the 1's in, and actually, if you think about it, one of these is gonna be 1, and the other one will be an 8. This and these two are the only places a 1 can go. However, let's just say at the moment we are able to place a 1 here. Let me. That means this hut is the only place an 8 can go. However, let's say this is an 8. We find out that we can place an 8 here. Well, the only place to place a 1 is right there. So these two, I can actually make a 1-8 pair. And this is now the only place I can put a 9. And let me see. I can now pencil mark right here. Um, the 3 in this block can go here because of that. So it has to go here, which means I can put this the 4-3 pair. So I can make this the 6-9 pair. And now this I can make a 3-5 matching pair. Which means this is the only number in this block that is not accounted for, which happens to be 6. And if you want to check yourself, you always can by going 6, middle, top. It will be somewhere here on the bottom. So that's right now. It looks like right now. And if you look in there, one of these or two of these will be an 8. This is sometimes called an X-wing. And what that means is the 8 will go in an X. It'll either go right there or right there. But either way, it's gonna go in one of these or one of the and one of these. That being said, we can say safely that the 8 will not be in any of the highlighted cells. So, in this block, the only place an 8 can go is right here. Let's see where we're at. Looks like it should be much easier now, but it's really not. I can pencil mark my 8. And it's really not that easy yet. It seems like it should be, but it's not. Okay, guys, I have to take another break, but I think I'm back for good. Um, but I want to say this can no longer be sex, so that means this will. And this one will be 2 because of that in the pair. So this is the only place I can have a 5, which means this is a 1, since that is the only number not accounted for. And this is a 3, means this is a 5. Here, I like to put in a group of 3 numbers if they fit in a row and a block or a column in a block. This is a column in a block, so I will put in a triple. 1, 4, and 8. However, that can't be 4, that can't be 1, that one can't be 8. So now, I could put a pair in here, 2, and 9. In this row, we need 1, 3, 1, 2, 3, and 8. But can't be 1, 2, or 8. So it has to be 3, which means this is the only place a 5 can go. It's the only place 6 can go. This will be the 1, 2 pair. This won't be 2 because of that. So it'll be a 1, 2, and that solves that pair, which solves this pair. Okay, so let me look now. In this block, 1 will go here, 2 will be one of these two, 3 will be one of these two. So this will actually be a 2, 3 pair, and this will be an 8. This will be a 6. So this will be a 1. This will be a 4, 8, 3, 4, 2. I'm sorry, 3, 2, 9, 2, 6, 9. These benefits of matching pairs. And let us complete the puzzle. So that took a long time, but we're finally done. I hope you enjoyed this introduction, and I will see you